Hello friends and welcome to my channel Bit by Bit. I'm again here after a long time and taking a question named Jump Game. This jump game has 9 variations. Can you believe it? 9 variations. It's like jump game till 9. So we are going to cover all the 9 variations for sure in this series. Okay. So let's see the question. You are given an integer array nums. You are initially positioned at the array's first index, which means this index first. 0, 1, 2, 3, 4. First, which means the initial index, okay? And each element in the array represents your maximum jump length at that position. Maximum jump length, which means, let's suppose we will take this 2 jump, which means, just a minute, let me make some staircases for you to understand it visually, that what a jump actually means. If a person is standing over here, okay, if a person is standing over here, then he can take a single step or 2 steps. That is possible for that person. He can he can take maximum 2 steps. At least he can take 1 step or he can take 2 steps. Okay. So this is what this line means, maximum jump length. Okay. So for this 3, either he can take 1 or 2 or 3 steps. Okay. So over here, if he takes 1 step, he will reach at 2 index. If 2, then 3, then if 4, then at the last index, 4th index. Okay. So this is what the question is, and return true if you can reach at the last index or false otherwise. Last index, which means this 4. Okay. So let me do a dry run for your good clarity. Okay. Yeah. So let's do it. So this is the person over here is placed at the initial position at 0, right? So now let's go ahead. So for 2, either he can take 1 step or 2 step. So let's take 1 step. Let's take 1 step and we will go over here. This is 2, this is 3, this is 1, 1 and 4. He have to reach at this index, okay? At this index. So he takes 1 step and moves ahead. He takes 1 step and moves over here. And then he takes again 3 step. There is 3 over here. Either he can take 1 step or 2 step or 3 step. If he takes 1 step, he'll reach here. If he takes 2 step, he will reach here. And if he takes 3 step, he will reach at the last index. So it will be better if we take 3 jumps. Okay. So he will directly take 3 jumps and he will reach at the last index. So here we will return true. Okay. So this is what the question is. Let's take a false example. Okay. So nums equals 3, 2, 1, 0 and 4. Okay. So again, let's erase this all and solve this particular example. Okay. So here is 3, 2, 1, 0 and 4. Okay. So here is the person standing at the initial position. 0, 1, 2, 3, 4. So the first index is 3. The value is 3. So either he can take 1, 2 or 3. So if he takes 1 step, he will go over here, which is 2. Then if he then he has 2 options. Either he can take 1 step or 2 step. If he takes 1 step, then he'll reach at 1. Then he can take maximum 1 step. So he will reach at 0, which means he is stuck over here. He can't go ahead or before. Okay. So he'll be stuck. So this 2 will not stick after the man reaches over here. 2, he will not take 1 step and he'll directly take 2 steps. Then again he reaches over 0. Okay. So let's backtrack, and from 3, let's not take 1 step. Let's take 2 steps. If he takes 2 steps, again he reaches over 1 and he gets stuck again. If he takes 3 step, again he reaches over 0. So it is impossible over here to reach at the last index. So here we will return false, right? So the thing over here which we should notice is the maximum index, right? This is 3. So what is the maximum index it can reach? If it is the last index, which is n-1, then return true. Either or you should traverse the entire array, right? So the thing to remember is max index. Okay, remember the max index, and we will solve again a good example from max index. So we will take over here max index. Okay, so initially it is 0. It is 0, 1, 2, 3, 4, 5, 6 and 7. Okay, so he's placed over here. He's the value is 1, so he can take only one step. So he takes one step and reaches over here. So here he can take either either 1 or 2 step. So here the max index which it can reach is 1. So it will be again changed to 1. Okay, so here either he can take one step or 2 step. So if he takes one step, he will go at index 2, and if he takes 2 step, he will go at index 3. Okay, so maximum index again changes to 3. So let's take max index. He goes to third index. Okay, so then here the value is 1, so he can take only one step. So the max index again changes to 4. Okay, so if he takes one step over here, then again here he is stuck. Okay, he is stuck, so we should backtrack and we should not take the one step. Again we should backtrack. Here it is 1 only, so again we should backtrack. We should backtrack to 2, and 2 has taken the max index, right? So we should not take the max index, and we should take only one step so that we can reach second index, which value is 4. Okay, so here it is 4. Okay, let's not mess it up. Let's clean it up so I can show you clearly. From 2 we will not take 2 steps, we will just take one step so that we can reach to second index, which value is 4, which can surpass the fifth index, which contains 0 value. Okay, so here the maximum, so the max index is also updated, right? If we backtrack, actually backtrack, I am just saying you, this is not a topic of backtracking. Okay, I am just saying you that we have to reverse back. We have to take optimal path for us. So this is the topic of greedy. This is a greedy approach, because we take such a path which is good for us in the future also. Okay, so we will take the fourth one, and it may take 1, 2, 3 or 4 step. But if we take 1, 2 or 3, then we get stuck. So we will take the fourth step. The maximum index again changes to 6, right? Because 2 plus 4 is 6, so it changes to 6. And then after reaching 2, we can take 1 or 2 steps. So here if we take 2 steps, we are out of the array. Therefore we will take 1 step and we will reach the end of the array, and here we will return true, right? So this is what the importance of max index. So let's write the pseudocode, normal pseudocode. So the pseudocode, just a minute. We have to initialize first of all n equals nums.length. Okay, so that is n, and we have to initialize max index equals 0 in the starting, because it is given in the question that the values will start from 1, so no negative. So we will start from 0. Okay, max index is 0. So now we will do a for loop, I equals 0 to n. Okay, I equals 0 to n. We will do if I is greater than max index, which means, look over here in this example, if this is 2, right? This is 2, and we are going to we have first taken the max index. We have gone to 3, and then again to 4, and then again to 5. Here we are stuck. The max index was also 5 over here, and we are stuck over here, right? So we can't go ahead. So that is why this particular condition is given. Okay, I becomes greater than max index, right? So if this condition arrives, we will return false. If we get stuck over a condition, we will return false, and we will if this doesn't happen, we will update the max index by max of max index comma I plus array of I, right? I plus array of I, which means if we are at 4th position, then second position, which value is 4, so we will do 2 plus 4, which is 6. So max index will be updated by 6, right? So this is what for loop would look like, and at the end, if the for loop is completed and we have reached till the end, we will simply return true. True. Yeah, true. That's it. This is the pseudocode. This is a normal approach, greedy approach, and its time complexity, since we are running a for loop, it is big O of n, and the space complexity is big O of 1. So hello friends, this is the problem which we were talking about in the explanation. So these were the example that we did the dry run on. So let's go on the approach. So we first took in n equals nums dot length, right? And we took again a max index, right? A max index which is equal to 0. Okay. And we were doing for loop int I equals 0, I is less than n, I plus plus. And in this we were doing if I is greater than max index, so we will return false. And then if not this, then we will, just a minute, we will update our max index. Max index equals math dot max of max index comma I plus array of I, right? Yeah, array, no, it's nums, right? So we have to update it to nums. And in the end, if it reaches the, if it completes the loop, which means it reached the end, right? So we will return true. So let's try to run this code. Hopefully it will run. It will pass all the example test cases. Indeed, yes. So thank you for watching the video.